So far, we have seen how to declare variables, how to do input and output, and we have seen also how to do, selection with if statement. All that is good. Now, the point is there are some tasks that involve some repetition, and these tasks need a special type of processing. Now, let's take an example to have an idea about why we need a special processing for dealing with some types of repetitions. Now, suppose we have a sale, a program that asks us about the sales within a week, and we need to calculate, for example, the average of the sales. Now, what we can do is something like that. So first we do cout, and we say, okay, give me sales in Monday, okay, and cin sale, something like that, and we store the sale in this variable. Obviously, here we just need to do declaration of the variable sale before the cin, and the job is done. Now, that's actually for the sale of Monday, and we need to, for example, here we say another variable, it's actually sum sales, which is initialized to 0. So what we will do is actually say, okay, sum sales plus equals sale. Okay, so every time we get a daily sale from the user, we add that to actually the sum sales, which is sort of, we can call it also the weekly sale if you want, whatever. Now, we have that for Monday, so this should be also done for Tuesday. Okay, and the same thing. This also should be done for Wednesday. So doing this program for a week, that's actually, a bit a tedious work. Repeating the very same block of code 7 times is very tedious, and we are wasting our time. Now, imagine that we have a program that requires repetition for a month, 30 or 31, iteration. That would become really harder. If we have something bigger than that, that's even harder, which is even worse. In some cases, we do not know how many iterations, how many repetitions, how many cycles, that call them whatever you want. We don't know how many repetitions we have in this program, and therefore a fixed amount of repetitions like this one will not work. Okay, so imagine, for example, that you are trying to keep a record of your daily sales in a store. Now, in a store, you might have 0 customers in an exceptional day, and okay, you also might have 10, 20, 25. No one, there is no way we can predict exactly the number of sales and the number of sales in a given day. We can predict a range, but the exact number, nobody has a crystal bullet to predict this kind of things. Therefore, we do not even have the number of iterations, and this whole thing may not work. It doesn't work, actually. Therefore, we need a special tool for dealing with repetition, for dealing with repetitions, and this tool is called loops. Okay, so the first form of loop is called the while loop. The while loop is actually a loop that repeats until a certain condition is met. Now, let's take an example here. So here, while I will start by declaring here int nb days. Okay, So NB days is actually is a variable that will tell me how many times my loop will keep repeating. Okay, so here I will get something like 7 because I'm assuming that I'm modeling a store that opens 7 days a week. So the number of days is 7, and I will have another variable which is also initialized to 0, which is the number of days that I already processed. Okay, so I will start with 0, and I will say while n is smaller than number of days. So while n is smaller than number of days, do the task. And the task, we know it actually already. So the task is getting the information about the day. So here we will say, okay, so in day number n, okay, number, sorry, n plus 1. So here we'll say day number 1 is 1 day, day number 2 suppose, so on and so forth. We'll take the number of the day. Later on, we will see how we can convert this number into an actual string of character. But so right now, let's not focus on this small issue. Now, what we do is actually here, this loop will start with n. We will start with 0. Now, every time we do an iteration, we will do the incrementation of n, so n plus plus. Now, can I do the plus plus here? Question? Yes, no? The answer is yes, because this is post incrementation. I will do the processing, then I will do the incrementation. So both approaches would work. Now, so while n is smaller than the numbers of days, so we start with n is equal to 0, increment every iteration by 1, so n will be incremented by 1. This is my counter, if you want. So my counter n will be incremented by 1, and by incrementing my counter by 1, I will go up and up until I reach the number 7. Whenever n is equal to 7, this condition will not be met. And again, remember, this is like an if statement. So as long as this condition returns true, I will execute the thing that is inside. But whenever it is false, I will not execute that blocks, and that will be the end of this whole while loop. And then I'll move into the next one. Okay, so just to do the kind of a sign for you here. Okay, so that's it. Now, if we run this program, first iteration n is equal to 0, it's smaller than number of days, we go and give me the sales in number 1, see in sales, and we add the sales to the number, the sum of the sales. Now, so on and so forth. Second iteration, and then n is equal to 1, then 2, 3, 4, 5, 6, then 7. When 7, this will return false, and we will stop. Now, we would like to see also here, after the loop, here is some sales. Obviously, if I want the average, I would just do, okay, I'll just do that. Okay. I will divide by the number of days, just to be, dividing by the constant 7 wouldn't be a good idea, because I may change. Suppose that the store decides to open 6 days a week or something like that. So this variable here can have a different value than 7. Having using a variable instead of a constant will help me keep my formula here, up to date whenever I change the value of the variable number of days. So now it's time to clean this part of the code. Some sales are already declared, number of days and n are already declared. Now, just if you allow me, I will not go for a number 7, just to, shorten the demonstration, because inputting 7 numbers wouldn't add anything, extra to the demonstration of the code. Okay, so here I will just go and say 10, 20, 30. So the sum of 10, 20 is actually 30 plus 30 is 60, and the average is equal to 3, and is equal to 3. So all the numbers, are, as expected, and the job is done. Now let's take 2 more examples of while loops to make things even clearer. Suppose we would like to print all the integers within the range starting from 0 and ending with a number that we get from the user. So suppose the user gives us the number 10, we will print 0, 1, 2, 3, up to 10, and we'll print 10. So it's inclusive, and it's an inclusive range between 0 and the limit that we will get from the user. Now, what we need to do is the following. Since the goal of the program is to print everything within the range, so we need to declare 2 variables. So here we say int lower bound. We said it's actually equal to 0, so we already know that. Upper bound, we don't know that, but we will get that from the user. So something like that, just to be fast. Cin upper bound. Okay, so we instantiated this variable from a value we got from the user. Now we know our lower bound and we know our upper bound, and we need to have another variable actually, which is counter, if you want. You call it counter, you call it CT, whatever, and the counter will start with actually, which is equal to the lower bound. Okay, so at the beginning, the counter is equal to my lower bound. Now, which means the counter will start with a value 0, then it will get incremented. Now, the while loop, I will keep repeating until my counter is equal to the upper bound. So while counter is smaller or equal to the upper bound that I will get from the user, I will keep repeating. I will get, iteration after iteration. Now, what I will do is actually just see out the current value in my loop, which is actually the counter itself. So the counter will start with 0, then it will get incremented until it reaches the upper bound, and of course I need to do the incrementation of the counter itself. Okay, so I got all the ingredients of my loop. I know the initial value of my counter. I know the upper value, the max value of my counter from the upper bound that I got from the user. Now, every iteration, I am incrementing the counter. Whenever this condition becomes false, I will stop looping. And whenever it is true, actually, I will keep looping. So just let's get some examples. Counter is equal to 0. So this is my lower bound, actually. So if the counter is equal to my lower bound, this is the initial situation. Lower bound, suppose the user gave me 10. So counter is equal to 0. This is smaller or equal to upper bound. That's true. Then I will just go and print 0 and increment 0 by 1. Go here. Counter is equal now to 1. 1, is it smaller or equal to 10? Yes. So I go here, print 1, increment 1. Now counter is equal to 2. Is it smaller or equal to 10, yes, I will go here and print the number, increment the counter, so on and so forth. And whenever the counter is equal to 11, actually this whole thing will not be true. Counter is not smaller or equal, so I will not print. However, when the counter is 10, is it smaller? No. Is it equal? Yes. So actually I will print. So this means that actually I will print everything between the initial value, which is the lower bound 0, and the upper value 10. Okay, now again, just for demonstration purposes, I will go for a small number for the upper bound just to avoid, a lengthy demonstration. Now, if we run the code, okay, upper bound, I will say, okay, 4. Okay, now we got actually 0, 1, 2, 3, 4 printed, which is actually, again, the lower bound and upper bound inclusive, and the whole range between them. Okay, now let's go for a more interesting example. Now let's suppose we would like to do a conversion of degrees in Celsius into degrees in Fahrenheit. Now, within a given range. So we will say, okay, within a given range of temperatures, we will convert everything, from this to that. And instead of just doing, one by one, we will take, a bigger step, and we'll see how we can do that. So here I will say, okay, lower bound, upper bound. So I'll just call it lower cell, upper cell Celsius. Okay, now this is my counter, which is actually equal to the lower bound. I'm just changing the name of the variables. Upper Celsius, and this is my upper cell variable. Nothing really, substantial so far. Now, what I will be doing here, instead of just printing the counter, I will just print actually the current degree. Okay, I'll just call this actually degree, and I will call this also degree, just to be consistent with the naming of the variables. So, and here we have upper cell. So now my program does everything the other one does. However, I don't want just to print the degree. I want to print the degree and its equivalent Fahrenheit. So we know actually that to get the Fahrenheit out of the degree, so we should have something. Okay, I'll just go. And so here I'll just go double. Is equal, so we declare the variable Fahrenheit, so is equal to 9 over 5. So 9.0 over 5.0, and that's a question now. Why I am adding 9.0? We know why am I adding 0.0 while we know that's not necessary from mathematical point of view. That's a question. Why I'm not typing 9 over 5? That would be more convenient, but why I'm doing this? Can anybody remember that? Yes, so the answer is actually it's because if we don't use float numbers or numbers in double numbers, C++ will do the conversion into integer, which is not exactly what we want. It's not as accurate as actually with the dot zero. So that is why we are actually doing this, just to say, hey, C++, I would like to get the result in as a float or as a double, not as an integer. So that's actually, again, that's a way to prevent C++ from converting this into okay, so here I'm just having a separator, and I will get the Fahrenheit equivalent. Okay, so now I have my lower degree. So the lowest degree is 0. I can start with any other number. It doesn't matter actually. And I will ask the user to give me an upper limit. Now here I have just a cin, which is fine. However, we need to think about the fact that the user may give me something that is not larger than 10. Suppose the user here in this case gives me 5, the whole thing won't work. It doesn't make sense. Now, yeah, for the moment, we will not need to, we will not do the input validation, but this is something you need to think about for, later processing. Okay, so right now, if we run this code, okay, upper cell, so we will say, okay, here we start from 10, we'll go for 20. Okay, so we have an incrementation by 1, 10, 11, 12. Okay, so, and actually we have the degrees that go with that. So actually the Fahrenheit, the degree and Fahrenheit that go with that, and that's good. Now we can actually do some checking of the program just to see that the result that this program is giving us is actually compatible with an existing tool, just to make sure everything is working fine. Now, if we compare the output of our program with the output of an existing online tool, we see that for 10 we have 50, so that's actually the expected the result we got here, and for 20 we got 68. So that means actually my program does the job as expected. Some of you might think, okay, yeah, this is not important. Why we need to do that? Whenever you have a possibility like this one of having a program to check against, I think it's a very good idea to go and to check your program just to make sure things are fine. That can save you a lot of time, because sometimes your program, there is a small bug, you didn't type the equation as you should, or you missed something, whatever. So it's always a good idea to check your program against existing tool if there are like tools like that. Now, to give you an intuitive example about a loop, let's imagine the following story or situation. We have a boy who would like to catch 3 magic fish from the lake and put these 3 magic fish in his fish tank. Okay, so to do an analysis of the situation, so at the beginning of the situation, we have number 3 fish in the lake, 0 fish in the tank, and obviously since he can only catch a single fish in his small net, he needs to make 3 trips from the lake to his fish tank. Okay, so how this trip will look like. So in trip number 1, he will take the first fish from the lake, and he will add a fish into that tank. Okay, so there will be 2 remaining fish in the lake, and there will be only 1 fish in the tank, in other words. Now, second trip, 2 fish are taken from the lake, 2 are in the tank, and only 1 fish is remaining in the lake. Trip number 3, it's actually where we have the 3 fish in the tank and no fish in that lake. And after this third trip, it doesn't make any sense for this boy to go back to the lake, because if his goal was to catch all the 3 fish, this is already done, and he needs to stop here. So all we have seen in this really intuitive and simple real life example is an analysis of what a while loop does. So every one of these 3 trips can be actually called an iteration in a loop, or in a programming language. Every trip is called an iteration. So here in this specific case, we needed to do 3 iterations to empty the take the 3 fish from the lake and put them into the tank. And so we can imagine actually that the number of fish in the lake and the number of fish in the tank, these are 2 variables. Now, if we go here and start to write the code, this is what we will see. Initial situation. So here I have int nb fish lake, equals 3, nb fish tank equals 0. So this is my initial situation. And if we go back to that slide, so this is what I have here. 3 fish in the lake, 0 in the tank. Now, I have a while loop here. And the idea is a way to write this loop is the following. We will loop over, and the only variable will be the number of fish in the lake. Now, can I use a single variable without any expression in a while loop? The answer is yes. Why? Because a variable with an integer variable. So an integer variable has a truth value. The truth value of any number except from 0 is true. The truth value of the number 0 is false. So the point is, if in the first iteration, then the value of my number will be 3, and 3 is true, so I will be able to enter inside of this loop. And inside of this loop, what I will need to do, I will need to do 2 things. Now I will need to do a decrementation of the number of fish in the lake and an incrementation of the number of fish in the fish tank. Okay, so every time what the boy was doing was actually taking a fish from the lake. So the number of fish in the lake was decremented by 1, and the number of fish in the tank was incremented by 1. So that sounds good, except that I need to actually what I need to do. So I just need to do some displaying. Probably I need one more of these. Okay, so NB fish in the lake. Okay, I will just also have another one. Iteration. Okay, now the variable iteration is not needed, but just to, I'll just have another variable called trip. Okay, and this variable will be initialized when I don't really need that, but just for our display purposes, I will just say, okay, here is my trip, first trip, second trip, third trip. So that's it. Now, number of fish in the lake, so that's actually the number of fish in the lake. And I will have also okay, so number of fish in the lake, number of fish in the tank, and so every time we enter here, we will display the number of the iteration, the number of fish in the lake, and the number of fish in the tank. Now again, what happens here, this number is being decremented. We start with 3, second iteration 2, third iteration is 1. So 1 we will enter here, so which means we will do 3 iterations. But when we reach the number 0, after the third iteration, this will be decremented. We go here, number of fish in the lake is actually 0, and the truth value of 0 is false. We will stop the loop and we will not enter here. To know the final state in the lake and in the tank, we need to write after we finish the loop. Whenever we finish all the iterations, we need to actually write how many fish we have in the lake and how many fish we have in the tank. And I can just write something like this here. So this is it. I think we're now ready to make a brief demonstration of the code. Now here, trip 1, we have 3 fish in the lake, 0 in the tank. Trip 2, we have 2 fish in the lake, 1 in the tank. Trip 3, we have 1 fish in the lake and 2 in the tank. And after we finish, actually, so at the end of the third trip, here what we have, the display is actually happening at the beginning of the trip. The state is at the beginning of the trip. So at the end of the third trip, which is outside the loop, or we can actually have that after this part, but I mean, I don't want to have 2 prints within the same iteration. So at the end of the third trip, we have 0 fish in the lake and 3 fish in the tank, which corresponds to the final stage in the slide. So no fish in the lake, 3 fish in the tank. Now we will have an example of an infinite loop. Now, infinite loop is a loop that does not stop at all. So we repeat an infinite number of iterations, or a theoretical infinite number of iterations. Now, why we would use that? As I gave you an example, actually, the idea is in some situations we do not know how many times we need to iterate. So for example, in the example of the fish in the lake, we knew that we had 3 fish in the lake, but in the real life, it is very hard to tell how many fish there is in a lake. So if you want to transport all the fish in a given lake to a tank or a set of tanks or a different location, the point is you don't know ahead of time how many loops you're going to make. And that's why the program we have seen in the previous example does not work. Now, let's suppose here we are talking about the number of sales in a shop. So here we will have while an infinite loop we can have something here while true. Now true is a constant statement that is always true. Okay, so this is an infinite loop, and in every iteration of this loop, we will do cout. Okay, so here we have, okay, so daily sale and cin daily sale. Okay, so suppose here we have double daily sale sum sales. Okay, so I don't know how many days actually I have to take into account. So I keep looping infinitely, and I take a every time I take the number of sales, and every time I will do sum sales plus equal daily sales. So this is actually a situation where I can have in a theoretical infinite number of iterations. Now, if suppose that, I mean, obviously this is not realistic because there is no way we can handle an infinite number of sales, and that doesn't make any sense in a real world application. However, what we can do is actually ask the user to give us a sentinel value. Now, obviously, sales are positive values, so whenever I have a negative value, that's an indication that this is not an actual sale, but that's the end of the data. So daily sale, here I'll say or minus 99. Okay. So whenever the user enters minus 99, I understand that the user does not want to enter the sale. The user just wants to stop the loop. Now, what we can do, see out. So I take the number if, so daily sale equals minus 99. I will break. Remember, since I have a single statement, I don't need the braces. So I will break. Break, what it does is actually stop the loop. Okay, so I will stop the loop and I will go out of this loop, and I will not need to actually deal with this operation, because in this case, if I do this operation, I will add minus 99 to the sum of the sales, which is just a meaningless, action. Okay, now what we will do, see out. Now, some sales need to be initialized to 0. Why? We need to tell C++ that the number stored in this variable is 0. Now, if I do not initialize some sales, what happens is that I have an undefined number here, and C++ will not be able to add undefined to a number. So here I'm saying there is 0 inside of this variable, and C++ will be able to actually add numbers starting from 0. Now if you run, I have here daily sales. So suppose my first daily sale is 1, second daily sale is 2, 3, 4, 5. Now suppose this is all the sale that I have. Now I type minus 99, and actually the job is done. So I have 3 plus 3 is 6, 4 is actually 10, 10 plus 5 is 15, so that's the correct number. Now let's take another run to show you that the number is not determined. So here I have 1 to minus 99, so actually I can have any number of items with this loop. Now, yeah, so we have expressed this loop with this way. There are people who use something other than true. They, for example, use 1. Now, 1 is a constant. Whatever happens here, it will not change. So this is a constant, and the truth value of 1 is always true, so that's actually what we wanted. So it's equivalent to the 0. I can have 8. I can have 9. Any number that is other than 0 minus 10, so will give me exactly the same behavior, but by convention, we either use true, which is what I recommend because it's so explicit, so clear, makes the code more readable, or we use 1, which is actually by convention the number used for true. Now, there is another related instruction to break, which is the instruction continue. So what it does actually is, let's take an example here. So if the daily sale is 90.99, suppose we will break else if daily sale is larger than 1,000 or 10,000, whatever amount. So we say cout and L, and we say larger than 10,000. Okay, so we have a nested if statement within the while loop, which is just fine. Otherwise, we would say cout, sorry, larger than 10,000, not larger than 10,000. So if the sale is larger than 10,000, we will print this message. If it's not, we will actually print that. Now the point here, if we print this message actually, we will print as well this one, and that wouldn't make sense. So if you run the code here, and suppose I say 1, that's not larger than 10,000, and I have a large amount here, it is larger than 10,000, and I get also not larger than 10,000, which is a sort of contradiction. Now, if I would like to avoid things like that, I will actually have to do continue, and this continue is actually instruction will do the following. We will execute this line, and whenever we reach the line where we have this continue, which is in this case line 68, so we will actually stop executing the rest of the code within the loop. Okay, so within the loop, this part of the code will not be executed. Okay, so which means that I will not actually print this line, and I will not also add the sale. Okay, so if I want to fix this issue, I can have this here in this case, and that will actually have the problem fixed. Okay, so here we have one, suppose, big amount, okay, larger than 10,000, which means actually continue prevented this other line from being executed and solve my problem. So in other words, break will stop the execution of the code, and nothing after that will be nothing after break will be executed, and no other loop will be attempted even if the condition still holds. So true is always true, nothing will change that. However, with break, I will actually stop this whole loop and do nothing after the break and do not do any other iteration. However, continue will actually stop the execution of everything that comes after it. So here we are still inside the iteration of the while loop. We will not execute these two lines, but we will keep actually the loop. We will not interrupt the loop. We will just prevent the lines that are after the continue from being executed.